All right, this is going to be part 3. And what we're doing is we are finding the area of this combined, these two segments, as a result of two sectors overlapping. So in the first video, we went ahead and we found the first of these, which was the lower part here, the lower part of that bit there, and that was created by the top sector. And we found that sector, we've calculated it by finding, first of all, the area of the sector, then the area just of the triangle bit, and then we subtracted the area of the triangle from the area of the sector to reveal the area of the segment here. And we found that to be 38.03 square meters. Then we went ahead and did the same thing again in part 2. This time, though, we're going to have a much larger area because we've got, in this case, the angle arms are 40 meters, not 10. The angle itself is 50. But when we come to find the overlap here, what we've got is a much larger area. So we've got 698 rather than just 87 or something square meters. So this is a much larger sector. By the way, I've drawn this so that these overlap. In reality, I haven't worked out that they actually would look like this. And these sectors probably wouldn't meet up quite the way I've drawn them. But that is not the point. The point is to say, what would these two be if you were to calculate them? So anyway, we calculate the upper part now of this. And to do that again, we find the area of the sector, we find the area of the triangle, the triangular part there, and we subtract the area of the triangle from the area of the sector to reveal the area of the segment. In this case, we found it to be 85.29 square meters. So the final part then is to say, well, what is the area of this whole thing here? What's the area of that bit? And the area of that bit then, so area of, that's called segment overlap, is equal to, and then what we're going to do now is we're going to add the two segments. So I'm going to call the one on the top, I'm going to call this segment 1, yeah? And I'm going to call the other one here, which was the one based on the one on the bottom, I'll call that segment 2. So here we go, so it's equal to the area of segment 1 plus the area of segment 2. So notice how I'm setting it out. We need to be scientific in this and mathematical. So don't just put something plus something equals. You want to say what it is you're actually finding. So in this case, the segment 1 was 38.03 square meters. We don't put the units in until we get to the end. Area segment 2 was 85.29. And then we added those two together. Let's just do it on the calculator so we can be sure we get it right. So we've got 38.03. We're adding that to 85.29. Let's see where that takes us. And we get 123.32 equals 100 and... Oh, I wrote it incorrectly, didn't I? So I'm just getting ahead of myself again. I'm trying to get to the end of the answer before I even have 123, and it was 0.32. Now this is square meters, and it's 2 dp. So what we've found is the area of this part here is equal to 123.32. That's going to be square meters. And that is our answer. Hope that makes sense.